Assalamu alaikum everyone. This is lecture 11 for CS116 Object Oriented Programming. In the last lecture, we learned how to implement inheritance in Python. Like we explored the very simple syntax for implementing inheritance. And there we observed that a child class inherits all the public and protected attributes and methods of its parent class. Actually, we did examples to prove this. And we also observed that a child class can add to itself any new attributes and method that we want to add to that child class. And we can change behavior of any method of the parent class by overriding it. In last lecture, we actually replaced some of the methods of parent class by providing an alternate implementation of the same method in the child class. In today's session, we'll continue the same concept of method overriding, but this time we'll see a variation here that we can use method overriding not only for replacing a parent's method, but we can also extend any method that is there in parent's class by using method overriding. And we'll talk about code duplication also. Okay, and one new thing that we'll do today is override this new method, str. So what is method overloading? Method overloading means that we can define a method in a child's class having the same name as some method in its parent's class. That means that we can have two methods having same name. One of them is there in parent's class and the other one is in the child's class. And how Python works? Whenever a method is invoked on an object, that method is first searched in the current class, and then we move up the hierarchy. That means that if the object belongs to child class, then what happened? Then that method will be searched in the child class first. If there, then Python will execute it from child class, and if it is not found there, then we go to the next class. That means we go to the next class in the hierarchy. That means to the immediate parent, and if it's not there, then to the grandparent, and then so on, right? Now, method overloading, it can be used to replace a method of the parent class. This is what we did in last lecture, but this sometimes results in duplication of code, as we were discussing towards the end of last lecture. So method overriding can also be used to extend methods of the parent class, right? So either we can entirely replace the method of parent class, or we can use that method and extend its functionality in the child class, right? And by extension, we can avoid code duplication. And for code duplication, we discussed that it makes the code looks clumsy, and also it can make code maintenance complicated. Like if you need to change the code, then you'll have to change it at more than one places if you are maintaining more than one copies of the same thing at different places. By different places, I mean in child class as well as in parent class. Okay, now if we want to extend the functionality of any method from parents class, then for that we'll have to access that method from parents class. Now let's see how we can do that. So there are two ways to do this. The first one is to use parents class name, like we used to access those class variables using their class names. So we'll be accessing methods the same way. And a second method is to use this special function called super. And what does this function do? It simply returns an object, a temporary object of the parent class, and that temporary object can be used to access attributes and methods of the parent class. Now let's see an example for this. I'm defining a class called parent, and I'll take it as parent class later. Okay, I'm defining a method here called method parent, and this method only prints this statement, a parent class method, right? Now let me define another class, and this class is called child, and this class is inheriting from this parent class, right? Now I am defining another method here, method child, and this method will access method parent of the parent class, right? Now if I want to do that, I have two ways, as I mentioned before. The first one is to use parent's class name. So here it is, parent is the name of that parent class, and method parent is the method name defined in that parent class, right? So that's how I can access that method of parent class. The second way is to use that super function. So for that, we can write this super, that is function, so therefore I'm putting those parentheses after it, dot method parent, which is the name of that method that I want to access from parents class. Now out of these two, you will use any one, right? Like you don't have to use both of them in the same code. You will use either of the two, right? Now I want you to notice here one thing, that self, if you are accessing using the first method, you are accessing method parent using the first method, then you have to include that essential parameter self there, right? But if you are using, if you are accessing the same method using the super function, then you do not have to mention this self over there. And the reason for this difference is that this function super, it returns an object, a temporary object for class parent, right? So whenever you access some method through an object, you do not have to specify that essential argument self, right? Now I hope you remember this from all those examples that we have done, that whenever we access a method from the main code, from outside the class, what we have to do, we have to first instantiate an object, and then using that object, we access that method. And there we never use this argument self, because that object name, it itself gets transformed into self, right? But if you are accessing from inside, then you have to specify from inside the class, then you have to specify this essential parameter self. So I just want you to remember this, that if you are using first method, you have to write self in parentheses, and if you are using this super function, then you do not have to write this self. Now let's apply that method extension technique by accessing methods from parent class to the example that we had been discussing in lecture 10. But before doing that, let's recall what we had been doing. There I defined a class animal, and this class animal had two public attributes, species and language, and we defined a constructor by overriding this init method, and then we defined two print methods, info and speak. And after that, I derived a class duck from this class animal, and since duck is a child class of animal, that means duck can inherit all these attributes and methods of class animal. And then we defined some new methods for duck as well, like beak type and set beak type, and we override speak method and info method, right? Because since we are adding an attribute here, so we wanted these print methods to print accordingly. So this was the hierarchy that we developed in the last class. So this is what we were doing in the end, in the last lecture. We were overriding this method info, but what we observed here is that we had to duplicate some part of code. Like this will work fine. The info method of duck class will override the info method of animal class. But the problem here is that some part of the print statement is common, right? This red highlighted part. So there is nothing wrong in it, because this is just a small piece of code, but this is just an example of code duplication. Like if we can access that method, info method of parent class animal, then we can do that partial printing using that info method of animal. And let's see how we can do that. So what I'm going to do here is I'm going to define this info method. In the last example, or in this example, we are simply replacing info method of animal. But now I'll extend this info method of animal to implement a new info method in duck. Okay, so this is the info method of parent class animal. Now in duck class, what I can do, I can call this method of parent class, and that will print half of the string, right? So for that, I can use either of the two methods. I can use that name animal dot, like animal dot operator, or I can use that super function. So here I'm using animal dot operator. So animal dot info self. So this will call the method of the parent class, and this is the remaining string. Like I want to append this string to the first half. So this function will first print species, language, and then it will append this beak type at the end. And we know that there is an alternate method for this using this super function, right? So here what I am doing, I'm not actually this will override parents method, but it will use some information from that parent method, and it's like extending that parent method to add some new functionality. So this is the scenario now which hasn't changed because we have only changed the implementation of that info method in duck class. Let's run some test code. I'm instantiating an object of class animal. I'm printing its info. It should print, two attributes, instance attributes, species and language. And now I'm instantiating an object of type duck. And then I'm setting beak type. And then I'm calling this method info. Now this info, since it has been invoked on an object of duck type, def is of duck type, so what it will do, it will execute the info method from this duck class. And in that, what we are doing, we are calling parents info method for partial printing, and beak type will be printed by this duck's info method itself. So it should print all 3 lines, and here it is. Now one more thing that I can do here is, or to that example is, we are setting beak type using that setter method. A preferred way is to make an initiator. So I can make an initiator method in duck class, and since same method exists in animal class too, which is the parent class, that means that we are going to override that init method. So what choices do we have? The problem is that if I implement this init method in child class duck, then two of the instance variables, which are species and language, they were initialized in the parent class. So one choice is that I initialize all 3 instance variable in the child class, right? Like I initialize them again. They are being initialized in parent class too, but I am providing the same implementation in child class as well, because this init method of child class will override the init method of the parent class. And the other a better technique is that I use init method of the parent class to initialize species and language. That means that I can call that parents class init method from child class, right? And after initializing those two instance variables, I can initialize the third one in the init method of the child class. So this is a better approach because again it will avoid code redundancy. So let's see how I can write that init method. So in class duck, which is inheriting from class animal, I am defining this method. So the user of this class can pass 3 values, S, L, and B. S will be assigned to species, L will be assigned to language, and B will be assigned to beak type. And then from inside this init, I am calling init method of the parent class, and I am passing S and L to the parents class initiator. Now we know that default values for these S and L, they are provided over there, so we do not have to provide any default values here. And once this initiator gets executed, that means species and language will be set, and then I'm explicitly setting this third instance attribute beak type, right? And we know that there is an alternate statement for this. We can use this super function to call that init method of the parent class too. Now I want you to note a couple of things here. First thing is that init is a dunder method. That means that it is automatically called by Python whenever an object is instantiated. But since it is a public method, we can call it explicitly too, like we are doing here. When we are calling that initiator of animal class, we are explicitly calling it for ourselves, right? So that means this is possible. You can call any of the dunder explicitly too, this way, right? And the second thing is that now since we are initializing this beak type in this initiator, that means that we no longer need this setter method for beak type. Now let's quickly test this. This is the current scenario. We have added this init method in duck class 2 now, which is overriding parents class method by extending its functionality, right? So here now you see I am instantiating an object defi of class duck type. So here I can provide all three values for the three instance variables right away. And if I execute this function info, which we have already overridden to print all the three instance variable, so this should print the complete info. Here it is. And then speak will print that specific message quack quack quack. So here it is. Okay, that was all about method overriding for user defined methods. Now let's see something new. Let's define a list type object and let's print it on a screen. This is how I can define a list type object, which is called my list here, and I'm assigning these three values to the list 1 2 3, right? And if I want to print it, I only have to write this, right? Now what output will it produce? This is the output. The list has been printed and it looks pretty nice. Now let's try the same thing for our animal and duck type objects. So here is an animal type object Tom, and I'm instantiating it to cat and mew. Like cat is the species and mew is the language. And if I try printing it using the same method, okay, this is what it prints. Okay, let's try this for duck type object also. So here is a duck type object called defi, and if I print defi, okay, it's print something similar. So this is somewhat technical. Like it says that this object, it belongs to class animal, and that animal class is defined in the main module at this particular address 0x044008BD0, right? And same is the description for this duck type object, but this is not very user friendly, or we can say that this is uninformative print representation. We cannot make much out of it, right? But if you want to print something presentable like we had there in list class, that is also quite possible. And for that, what we have to do, we have to override another dunder method, which is called str, right? So let's implement this method for these two classes, animal and duck, and let's get rid of this technical information that is printed at the output. Now first let's see what this dunder method str does. This method is automatically executed by Python when an object is printed, like we were doing in the last slide. Like if you use that print statement to print an object directly, then this method is called at the back end, right? And what it does, it simply returns a string, and you can set the string in this particular method. Like, you can set a string of your own choice, whatever you want to print at the string, that can be set in this method, or you can say that can be returned using this method, and that will be printed when that object is printed. Now let me show you a small example first. I am defining here a new class called representation, and I am defining this method here, str. Actually, this method is from that base class object, because this representation is inheriting, by default from that class object. So I am overriding this method, and here I am providing uh, some print statement, right? So this method simply returns a string, and whatever string it returns, that will be printed when I print this object representation. So now to test this, I make an object R of this type representation, and then I print this object R. Here's the output. So what's happening here, when I printed this object R, it called this method str at the backend. Because it's a dunder method, that means that it is called automatically when this print statement executes, and this returns this string. So this string gets printed in place of that object R. So that means whatever you want to print when you are printing an object, you can simply put that in this str method. Okay, now let's apply this concept to our own classes animal and duck. Now, first of all, we'll have to decide what kind of output we want when we print an object. So let's talk about this class duck first. Here I am instantiating an object of duck type. That object is called Defi, and I am providing three initialization values. Duck will be assigned to the instance variable species. Quack will be assigned to the instance variable language, and long and curved will be assigned to the instance variable beak type, right? Now, if I print this object Defi, what kind of output do I want? This is one possibility, that I want to print the values of these three instance variable, and I'm putting these values in these, what you call these triangular brackets, right? This could be one way of printing it, or I could make it more fancy, and I can print it like this. Like, so that means first you have to decide that what kind of output you want, and whatever we want, we can simply put that in that string method. Okay, I'll go with the first method or the first output. So let me define it, this method str method, for this class animal. So here is the string that I am returning from this method, and this is pretty much self-explanatory. The starting triangular bracket plus this string, species of string type, so I do not have to convert it to string, and then I'm putting a comma in between, and then I'm putting the second instance variable, which is language, and then I'm at the end I'm placing the ending triangular bracket, right? A similar implementation can be made for class duck. Here it is, right? Let's test this now. Okay, this is the code. This is the first animal type object, which is Tom. So if I print Tom now, okay, it is printing in much presentable way, right? And here I'm initializing Defi, and then I'm printing Defi. It should print these three values, and here it is, right? So now this output is much better looking as compared to the one that we were getting before overriding this method str. Here I have a question for you, that if I remove this str method from the child class, that is duck, then what output will this last statement print Defi will print? Like you can obviously run it on idle, but I don't want you to run it there. I just want you to think that which str method will be executed in this case. Okay, let me show you something interesting here now. Okay, here I am instantiating an object of animal type called Tom, and then I am printing this object Tom. Now, can you guess what output will this statement produce? Because the different thing here is that I am not initializing Tom to any initial values. So what should it print? Do you remember that? You can pause here and just think about it. Okay, what will it print? It will animal class has two instance variables, uh, species and language, and since we are not initializing them to any value here, that means that they will be initialized to the default values, and the default value for species was animal, and default value for language was talk. So it should print the object, and this is the output that we'll get here, right? Animal talk, right? And since we have overridden that method str, so it is printing this object nicely the way we want it to be, right? Now let me execute this function type on Tom. I hope you remember this from last semester, that whenever we want to find type of an object, we used to call this function. And it, for example, if I take an integer 12 and I call this type function on 12, it will return to me class integer, and at that stage I told you class simply means type. So 12 is of type integer, or you can say 12 belongs to this class integer. So here, okay, we are asking for the type of Tom, and this is the expected output. Class main animal, or you can simply say class animal. So that means Tom belongs to this class animal, or you can say that Tom is of type animal, or type of Tom is animal, right? And this main, before written before this animal, main dot animal, main means that this class animal is defined in the main module, right? So that means uh, what we have done, we have created our own class. Animal is our own class, or we can say we have created our own type called animal, right? And this type function works with it the same way as it works for other types. Now let's run these two statements for the class animal. Now here I am trying to print animal. And now here animal is not an object, but this is a class blueprint. So obviously for this our str method will not be invoked. So this is a class, so it prints something like this. And now this is pretty much justifiable because animal is a class, it's not an object. So class animal, which is defined in main. And if I now want to find out type of it, so basically animal itself is a type. So this is the output that we get. Animal is a type, or you can say that animal is a class, it's not an object, right? When I called the same method type for object Tom, so Tom was an object of type animal, but animal itself is a type, so that's why it is printing here that it is a type. So that means now we are sure that we have defined our own type called animal. And one last thing here is that there is this function is instance. We can call it to find if an object belongs to a specific class. Here I am passing Tom and animal to it. So what I want to find here is that if Tom is an instance of class animal. So Tom is an instance of class animal, so it should return true. And here it is. So these all these functions type and is instance, they can be used as housekeeping functions. They might come handy at some point while debugging the code or so. Okay, now in order to wind everything up, let's do a practice problem. Here we have to implement a class shape having only one attribute, number of sites, and we have to set this attribute in the constructor. And we have to set it to 1 by default. That means that init method, we have to implement one init method for this class shape. Okay, from this class shape, derive a class rectangle, and this rectangle will have two additional attributes, length and width, and it will support the following methods. Perimeter, it will return the perimeter of the rectangle using obviously these two instance variables, length and width, and area will return the area of the rectangle. Okay, we also have to define another constructor or initiator here for class rectangle, and this will initiate length and width to 0 by default and number of sites to 1. That means that we'll have to call the initiator of parent class for number of sites, and remaining values will be set in this new initiator. Okay, the object when printed should display the following. Okay, this means that we have to override that str method too. Okay, in the end, we have to write this test code. We have to take values for length and width from user, and then we have to instantiate an object using these values, rectangle object using these values, and then we have to print that object on a screen. Okay, now I want you to um, pause here and do this problem by yourself, because the remaining of the lecture covers solution for this problem. So a better way is to do this by yourself first, and then you can come back here and see my solution and you can compare yours with it. Okay, now let's implement this class. First we have to develop code for this base class shape, and as per description we have to add only one method here, that is the initiator method, and this initiator method will set an attribute number of sites to 1. So this is the statement that I should include here. I think it does not need any explanation. Okay, after this I have to code another class rectangle which is derived from shape. So this is the syntax. I have to mention shape in those round brackets, and then the first method that I'll implement is the initiator method. Now this initiator method will take three values, one for number of sites and one for length and one for width. What we had planned was that this s we'll pass it to the initiator of the parent class, so I don't need to set it to any default value here. So this is how I can call the initiator method of the parent class, and I'm passing s to it. It will set number of sites to s, and if nothing is passed then it will be set to 1, and I'm setting the other two values, other two instance attributes. Okay, this is the third method that we have to code, perimeter. This will simply use the parameter formula for rectangle, and this is it. This is quite self-explanatory, and same is the case for area. Now let's implement the last method. We have to override str method also, because we have to print the object in a certain format. So this is the method definition. Okay, now this string method returns a single string. That means we have to arrange that whole information that we are supposed to print on a screen in a single string. So let's start by printing number of sites. Okay, here one thing which is different from the last example that we had done is that all the instance variable in this example, they are of type integers, and since this method str it returns a string, we have to typecast those integer attributes to string. So here you can see sites colon, it's a static string, and then I'm converting that instance variable number of sites to string and then concatenating it to the to my rest of the string. Okay, and then that backslash at the end, it's a continuation operator. Then I have to put this second info set of information, length is equals to something, on another line. So I have to put backslash n by myself because I cannot use a different print statement here. And same is the case for self dot length. I have to typecast it to str. Width, same thing done with width. Okay. Now for perimeter, the different thing here is that I do not have any instance attribute perimeter. I have a method that calculates perimeter, so I'll have to call that method over here. So that's how I'll do this perimeter method will return perimeter as an integer. So again, I'll have to typecast that returned value into str. I hope this is not difficult. We have done this so many times in CP2, and this is the last statement, right? So that's how we put all the information that needs to be that we need to print on a screen in just single string. Okay, now in main program, what we are supposed to do, we are supposed to input values for length and width from user first. So let's do that. Okay, we are using this function, input function, for the first time in this course. So let's input this value from user. I'm assigning it to L. So it will print this on screen, and let's suppose 4 is the value that the user enters. Then we input value for W in the same way, and this will print this message on screen, enter width of the rectangle, and let's suppose user enters 3 for this. Okay, once we have obtained these values for W and L, I can instantiate a rectangle object. So here's my object. For number of sides, I can set it to 4 because rectangle has 4 sides, and then the two values L and W, they are the ones that I have just taken input from user. Okay, so the object is ready. We only have to print this. And since we have overridden that method str, that means that this should print the required result. So here it is. So I hope your implementation matches mine and you are pretty clear with the concepts that we have covered up till now. So that's it for today. Let's recap it quickly. Overriding, it can either replace a parent's method or it can extend functionality of that parent method. Extending parent's method means that we are trying to avoid code redundancy. We can access method or attributes of parent class, and there are two methods for that. One is the super function and the other one is by using class name. Then we saw this method str. This is automatically called when an object is printed. So this can be used if you want to print something of your choice on screen when an object is printed. And lastly, we know that class defines the type of an object. So that means that now we can define our own types, right? Thank you.